I just invited you.
I thought we get invited.
What's that?
Even though we're right here. Makes me happy. I should probably wash my hands.
Oh, yeah. Especially if you're going to eat out of that breakfast basket.
And that's why I was like, I would have an apple. And I was like, I should probably wash my hands before I eat that apple. You can get under the chair contraptions.
Watch out for those chairs.
We're kind of everywhere. It's kind of.
I don't know. He just left.
Here.
Oh, he just arrived.
Am I allowed to use this garbage can?
Yeah.
No, that's from my experiment.
It's RJ's experiment. Floating garbage can experiment.
I have to make it float now?
Well, kind of. Using springs.
Alright,
Did you guys get the invitation?
one sec. I haven't looked at my Google yet.
All right. Get an invitation to the.
Apparently I don't have any notifications.
Oh, really?
Oh, there we go.
Oh, you got one? Okay.
1428.
Sounds about right.
Cool. Okay, got it. Join. Use the mic. That would be bad.
Did you have some paper?
I was going. I just got here.
I'm high maintenance. I'm demanding.
Is anyone else joining us?
RJ should.
Anyone else?
Luke might. I sent an invitation to Reed.
I can actually talk to Reed today. I felt like I was ignoring him, but I felt really bad. Hey, you still have that card? He told me to put his name on.
Oh, yeah, I do. It's in my mailbox.
Okay. Speaking to the group, your microphone is muted. Thank you.
Am I?
No, mine is.
Oh, okay.
And
All
it
right.
just, I'm not going to like right.
Can you theoretically hear my voice coming into the speaker? Okay, yeah. Just wondering. What's the derivative of cosine?
Hold up, I just wrote the title.
RJ, what's the derivative of cosine?
Of what?
Cosine.
Negative sign?
Yeah, that's right.
We used to write down the PX, QX.
Yes, actually, we're going to start out, we're going to look at the proof of the product rule to start with. And I'd like you to know be able to reproduce the proof of the product rule. It's really long, but it's really long. I don't even know if I can fit it on the board so that it's legible. And we're just waiting for Raymond Plum to join.
I'm still getting photo courses.
Told y'all!
Do you even have courses on your phone?
Nope.
No.
Well, depends if you count like
Hold your props then.
horse power.
Do you have cows?
Used to have. Not anymore.
Okay, RJ is almost ready.
Hooray.
Mute your mouth!
Raymond Plum has arrived. He's entered the building. Okay. That's wonderful. So, guess what we use the product rule for?
Finding products of things.
No.
The derivative.
Of
Sine and cos.
Nah.
multiply together. Correct. Yeah.
Yeah, that's what I meant.
So,
What
yeah.
do we do with tan?
What do we actually
Easy candy.
we deal with tan the same way. Yeah. What is the derivative of tan? RJ?
It's like secant squared or something.
Yeah, it's secant squared, and it's not that hard to. Not
It's
that hard to
stupid,
do.
I don't like it.
What's that?
It's stupid.
You're down.
Easy there.
Yeah, boy.
Like, I
don't be
couldn't
so
even talk
flippy.
yesterday, but I wasn't feeling like that. Jeez.
All right. So what we're going to do, we've got the product of two functions, and we're going to derive the. We're going to find the derivative.
I knew I should have took
Using
pictures
first
when
principles.
you were more-
Oh,
I knew I should have took pictures of it.
But
took pictures of what?
During second period, he wrote down the entire product rule on the board.
Thank you very much. Sure.
Thank you. What's that?
magic documents.
The magic documents, for which I haven't yet done Natalie's interim report. Okay.
Oh yeah.
So I want to find the derivative of f of x. What do I need to use?
The product rule.
The product rule. Yes, I need to start out with the difference quotient. So,
It's equal, I saw this. It's px times qx, or the derivative
p at
of
x plus
qx.
h.
What?
Q at x plus h.
Tell me some derivative of.
Yeah, this is just the difference quotient.
Yeah.
This is how you told me otherwise. This is a lie.
What's that?
It's a lie.
Already, RJ is upset already. Okay. We have to do a magic trick in here because we don't have any tools to deal with this right now. We have to do a magic trick, and here it comes. We want to be able to make this a recognizable difference quotient for p at x, and so I'm going to subtract p at x times q at x plus h, and then I'm going to add it back in so that I don't change the expression in any way. Okay, that is kind of a very abstract move.
I don't have room for it.
Yeah, I know. I'll barely have room on the chalkboard for this.
See? That was a little-
Okay,
Please take a couple steps back from Megan.
take a couple steps back. Okay.
Okay, almost, but not really.
All right. RJ, look at p at x plus h minus p at x. That looks an awful lot like the difference quotient for just the p at x function all by itself. So what we're going to do, actually, we're going to factor out this q at x plus h part.
There's a lot of those. Great.
Yeah, there's a lot of that. And so there we go. And things start to look a little bit more familiar. Now I'm going to split this into two fractions, but I can do that. Yeah, it's plus. And what I'm going to do is I am going to factor, I'm going to factor p at x of these two, and that's going to leave me with the difference quotient for q at x. So I'm just going to factor p
Is
at
that
x
times
out.
the bracket or minus the bracket? Like the
Times.
square brackets.
Yeah, that's a times in there because I just factored it out. Yep. P at x and q at x plus h minus q at x. And that's all over h.
There's no more on that line, right? So I'm.
That's it. I have it. It's all
I'm
over.
out of room.
They're all out of room? Okay. I could come out of room too. Is it visible?
It's pretty good. Some of your cues are a wee bit.
My cues are a little bit funny.
Hi. Just because you don't know how many on. You've been joined.
Oh, we've been joined. It's muted. Is that Luke? Is he waving? Hi, Luke.
And he can't see you.
He can't see me? Oh, look at
There
that.
you go. Now you
Oh,
can see
okay.
you.
All right. Hi,
The
Luke.
camera's there.
Yeah, it's a little bit irritating. So it's irritating to look there and not there. So we're just going through the proof of the product rule, Luke. And as I mentioned, I'd mentioned earlier, this is one of those proofs I expect everybody's going to be able to reproduce, even though it's kind of ugly. So we have a function. It's a product of two functions. We just put the whole thing in the difference quotient. And then we do this magic thing where we add in something that looks kind of like a part of the difference quotient. We subtract it back out. And we start to get our two difference quotients and two functions forming down below. So I'm about to turn this thing into something that is manageable. So I'm going to erase this stuff up here, except for the limits because I'm kind of lazy. Look at that. The limits are already there. Laziness.
Well, I have my microphone muted.
Yeah, there we go. All right. That's better. How did chemistry go yesterday?
Oh, it was good.
Oh, okay, good.
Didn't take too long. It was good.
Okay, so that's the difference quotient for P at X. That's the difference quotient for Q at X. I am actually ready to, I'm ready to apply my limits here. I can actually do this right now.
Do this.
Let's do this thing. Okay. So I'm going to put H in, I'm going to find the limit as H approaches 0. Q at X plus H, and H is 0. What's that? Right, it's Q at X. And then, what does this become? The difference quotient. How do we write that out?
Well, the P at X minus P at X, so it's 0.
It's actually, it's the derivative of P at X.
But it's P at X minus P at X.
Well, it's P at X plus H minus P at
And
X.
if you put it in 0, it's P at X.
Well, I'm dividing it by H though. So it's just, it's the difference quotient. So,
Oh, I see what you're doing.
yeah, so it's actually the derivative.
Gotcha.
Yeah, pretty handy, eh? And then plus P at X times Q prime at X. So this is the difference quotient. This winds up being the derivative of the function Q of X with respect to X. So there we go. That's it.
Divided by 8, right?
No, because I applied my
Oh, you
limit.
did that. Okay.
The H is all gone.
Sorry.
Yeah, that's right. And fortunately, because I'm applying the limit, I don't end up with the division by 0 thing happening there. So it's just, there it is. That's the product rule. And normally I sing a little song about it. First times the derivative of the second plus second times the derivative of the first, but we turn it into a chant. It's pretty cool. Okay. Is everybody good with that? So, this is like the second times the derivative of the first function plus the first times the derivative of the second function. Second times the derivative. Yeah, and you could put it in any order. First times the derivative of the second plus the second times the derivative of the first. Doesn't matter. Okay. Luke, what's the derivative of sine x?
What?
Oh, sorry, you're coming through kind of spotty. Do you know what the derivative of sine x is?
Me? Sorry.
Yeah.
He can't see you looking at
Oh, he
it.
can't see. Okay, jeez. Yeah.
No.
Oh, okay. So the derivative of sine x is cos x. You don't actually have to know this technically for this lesson. So it should be all right. Okay, let's do some examples.
What?
Okay. So let's find the derivative of hx. Oops. So we're just dealing with all polynomial functions.
I'm still wearing the lab coat. Oops.
Like very sciencey.
I am very science.
Yeah. Okay. So it always seems a little artificial because these are like two polynomial functions, and if you're of the arguing type, you'd say I could just expand this and take the derivative, and it would be easy, and you would be right. There would be nothing wrong with saying that. Okay. Sometimes it's nice to break these things up into the two functions. What's my first function? 4x squared. Very good. What's the derivative of the first function?
8x.
8x.
I think it's a cube.
Excellent. Yeah, that's a cube. People
Yeah,
are
it's kinda hard to tell on the
questioning.
screen.
It's hard to tell. Okay. What? That's a perfect cube on my screen.
Your screen's so clear. And then ours was just kind of like.
Luke can see, right, Luke?
Yeah, that's good.
Okay.
RJ says his headache's messing with his vision, so.
Oh, okay. All right. Okay. P at x. Who wants to take a shot at P at x? What is it, first of all?
2x cubed minus 4x plus 9.
2x cubed minus 4x plus 9. Yeah. And P primed at x?
6x squared minus 4.
Yes, sir. That's actually all we need to, that's all we need to move ahead, move forward. Okay?
I can handle that.
Yeah, it's pretty easy. The hardest thing is maybe the proof, and it's because it's got that counterintuitive thing. Okay, if I erase this, everybody's cool with that? Okay, so 4x squared times 6x squared minus 4 plus, tell me if I get this wrong, 2x cubed minus 4x plus 9 times 8x. What a mess. And you know, you can expand that if you like, and collect like terms, or you can leave it like that. It'll tell you if you're supposed to expand it or not. Okay. Everybody cool with that? You gonna look at the camera? Cool with that, Luke?
Yeah.
All right. Ready for another example?
Yeah.
Okay. You guys have that?
Yeah. There's a yawn. Okay. You just look like you're dying. And I feel bad.
Yeah. RJ would be the first person to die in the middle of a video conference.
We totally would though.
You know, RJ, if you do that, I'm gonna get an awful lot of views on YouTube, right?
We're gonna get on the popular page.
James says you'd like to talk about that, right?
What's that?
James says like he would like to talk
Like to talk about
channel.
my YouTube channel. Oh, that's a little bit of an exaggeration.
He says he wants to talk to him an entire period about it.
Okay, that's it. We're gonna have a meetup after school. Okay.
He said something about his teacher being his neighbor.
Okay. What's PQ? P. What's P at X?
Root X plus 1.
Root X plus.
Yeah,
Oh yeah. Root X plus
We're
1.
doing a new example.
Very good.
Get with it.
What's Q at X?
It shouldn't say F prime, should it?
Oh. Yeah, you're right. It shouldn't say F prime. Apologies, all you folks at home. Shouldn't say F prime. Q at X.
3x squared minus
3x squared minus 5x.
3x squared minus 5x. Good. Oh, darn it. I'm doing my P primes below. I did them the other way
that's
on
why I
before.
was really, that's why I had that like, oh my god, look. What are you doing?
The oh my god, look. It's going in a different order. Hey,
I'll help you.
hey, what's your language? This is the internet.
The internet.
Do I have to convert this into an exponent and then take the derivative using the power rule?
Yeah.
So this is the x to the 1/2 plus 1. So what's the derivative of that?
Half x minus, or half x negative to the exponent.
Half x to the negative
You know
1/2 plus 1. Yeah, that's
Yeah,
right.
that. I
Yeah,
just can't
that's
see.
it. Okay. And yeah, when you get super cool at it, you'll recognize how to manage that radical right away.
Super cool.
Cute it. Yeah, we have different levels of coolness.
6x minus 5.
6x minus 5.
Nice.
Oh, and
Yeah,
thanks for pointing out that.
I was going to. They didn't go pick it up though.
Okay. Did we do derivative of the first times the second? We did, didn't we?
Did we?
Well, I always sing the song the other way around. Okay, so f prime at x is equal to the derivative of the first times the second.
Did you just do a derivative?
Pardon me?
No, he's just doing it differently.
Oh, alright.
Yeah.
I see.
Plus
No,
the derivative of the second times the first.
When,
Oh,
like,
look.
does it matter?
Hey,
when you,
hey everybody, what's wrong with my p at x
Yeah, I was
derivative?
gonna be like, well, what are you writing?
What's wrong with this derivative?
There shouldn't be a 1 there.
Yeah, derivative of a constant.
Uh,
There we go. Sorry, everybody.
So.
Yeah.
It's derivative of the first, right? So that should that not be,
That should not have, should that?
Shouldn't
Yeah, that
have
should
a
be
that shouldn't have a one.
and does it
That should
matter,
have a one.
like, do you need to keep it in exponent form, or can you put it back with like the root?
Yeah, you can put it back.
I don't like that.
Yeah. Yeah, you can leave it as an exponent. It might. I don't know. It's a style thing.
I just like that.
People fell in love with surds a long time ago. Believe it or not, these are called surds. Isn't that absurd?
Who's surds? Why are people in love with them? I like that. I'm in my webcam and you're just like,
I'm trying to see past the tower.
it's just kind of fun.
All right.
You're still going in my webcam.
So that is the derivative, and it's unsimplified. If you look in your notes, actually, you find that the derivative of this particular function does not exist for x being equal to or less than 0. Okay? As long as you're greater than 0, everything is fine. But the derivative does not exist at 0 because the left-hand limit does not equal the right-hand limit. A little bit of weirdness. Okay. Everybody good? Okay.
I'm just glad to just listen to this. I'm really don't look in the mood.
So last thing we're going to do, so these are all just examples with polynomial functions. Some of them done incorrectly, just to keep you on your toes, is the derivative of 3 functions multiplied together.